Hi everyone, in today's lesson we are going to learn about converting exponents to logs and vice versa. So the first thing that we want to do is recall or understand the definition that a logarithmic function is the inverse of an exponential function. And as we discussed yesterday, all exponential functions are in the form y equals b to the x. So the inverse would be x equals b to the y. Switch the x and the y values. So let's pick some exponential function. Let's draw it here. So everyone should be drawing that in there right now. That's an exponential function that goes through the point 0, 1, and let's give it a name. So let's give this the name y equals 2 to the x. 2 is an exponential growth model because the 2 is greater than 1 and it's increasing. Okay, now let's draw in the line y equals x, and let's label that. Okay, and now let's draw the sketch of what the logarithmic function would look like. So it would look like this. And then this would go through the point 1, 0. Okay, so again, just to reiterate, this red graph here is the logarithmic function. That's the inverse of this exponential function because it's flipped over the line y equals x. So let's now talk about the equation of this log function. I said I wouldn't talk about it until now, so now I think we're ready. Okay, so when we switched the x and the y values here, so we said y equals b to the x is this exponential form. So we flipped it and it would be x equals b to the y. So let's flip this to get the equation of that. So this would be x equals 2 to the y. So this is your logarithmic function, x equals 2 to the y. But this is funky. I don't like it writing it this way. We can write x equals 2 to the y as y equals log base 2 of x. And we're going to discuss how to go from this form to this form in an easier fashion. But first I want to write down a few definitions. Okay, first, the base of an exponential function is called the base of the logarithmic function. Okay? So what do I mean by that? So when we have an exponent, here's the base, here's the exponent, or the power, base power. So when we say log base 2, you see how I've written the 2 below the log? That refers to it as a base. So all bases must be written below the number. So log base 2 of x. So here's the base here, here's the base there. So let's put this into a definition. So by definition, x equals b to the y is equivalent to y equals log base b of x, where this function here is read log base b of x, which I've written here for you. Okay, let's move on to the next page. Okay, a few things before we can go ahead and convert. Logarithms with base 10 are called common logs or common logarithms. When the base is not indicated, a base 10 is implied. So if I just say log x, I really mean log base 10 of x. And logarithms with base e, that e that we talked about a few days ago, are called natural logs. So if I say log base e, we call it ln of x. It's just the notation that we use. So natural logs say ln. Log base 10 is the same thing as just saying log of x. Okay, now I think it's time to start converting. The method that I like to use is what I like to call the loop-de-loop method. So with this method, you always want to start the loop at the base. So let's write that down over here. Start loop at the base. So we're going to start our loop at the base. The base is b. We're going to go up to the a and back down to the e. So b to the a equals e. So b is your base. So the base of the logarithmic is the base of the exponential. So b to the a equals e. Follow the loop around. B goes up to the exponent. B to the a equals e. Come back down to equal. So let's look at these problems here. Let's rewrite each expression in exponential form. So we're going to go from log to exponential form. So watch, we're going to start at the base, go up to the power equaling this number here. So the base is 9, 9 squared equals 81. So 9 to the second power equals 81. How about log of 1,000? Just like I discussed up here, if the base is not written, what do we assume? So we assume base 10. So if it helps, we could write this in 10. So now let's do the loop-de-loop. We start at the base, go up to the 3, come back down to the 1,000. So 10 to the third equals 1,000. Okay, how about we look at example number 3? ln of x equals 3. Well, ln of x we know is the same thing as log base e of x. So if we want, we could write this as log base e of x equals 3. Now you can do the loop-de-loop. Start at the base, go up to the exponent, come back down. So e to the third power equals x. Okay, same thing here. For number 4, log base e is the same thing as ln of x. So log base e of 4 equals what? We don't know what this is equal to over here. This just says ln of 4. So can't we just write, we don't know, so can't we just put an x here? So start at the base, go up to the power, come back down. So e to the x equals 4. Okay, same thing with number 5. So number 5, we don't know what this is equal, so we could put equals x. Start at the base, raise up to the exponent. So 5 to the x power, come back down, equals 1 over 25. That's it. So we're going back and forth between logs and exponentials. Why don't you see if you could take a minute and do these 5 questions and then hit resume when you're done. No cheating. Okay, here are your answers. Okay, so let's just go over a few of them. ln of e's and ln of 1 both have log base e. So we could write these as log base e of 1 equals 1, log base e of 1 equals 0, and then do your loop-de-loop for these. So that's how I got those two. Same thing with number 8. We don't know what it's equal to, so we can put an x, and there's no base, so we could put a 10. So 10 to the x equals that. Now this one's a little backwards. The loop is going to go this way to the answer, and that's okay. If you have any questions on those, please circle the ones you had trouble with and ask us in class. Now I think it's time we move to rewriting each each exponential into log form. So remember we said the base of the exponent is the base of the exponential. So if this is a base of 2, I'm going to start with log base 2. If this is the base of the exponent that's a 2, I'm going to start with this base. So we'll say log base 2. If this has a base of e, I'm going to start by saying log base e. If this has a base of e, we're going to say log base e. This is the base, that's the exponent, so we'll say log base 25. So now we have to figure out what goes in this spot, and we have to set it equal to something. Right? So we can kind of do this whole reverse loop-de-loop method. We would go 2 to some power equals this. 2 to some power. So the powers here all are going to go here. So 2 to some power equals something. So the power that I have is 3. So 2 to the third power equals 8. Check the loop-de-loop and see if it works. 2 to the third equals 8. Perfect. 2 to what power equals something? Well, the power up here is 2 equals 4. So 2 to what power equals 4? 2 squared, 4. Beautiful. E to the 5th equals x. So e to the 5th equals x. So 5 and x. But this one, we don't want to write log base e. Log base e is kind of obsolete now. We use ln. So we would write this as ln of x equals 5. That would be the appropriate answer for this one. Okay, the second one. E to some power equals something. E to the 4th. So the 4th power goes over here, and the 2x goes in here. Again, we're probably not going to use log base e, we're going to use ln. So we say ln of 2x equals 4. Okay, then how about number 5? 25 to what power equals x? Well, 25 to the 1/2. 25 to the 1/2 equals x. So the 1/2 goes here, the x goes here. Okay, why don't you take a minute, see if you can do these 5 questions again, and hit resume when you're ready. Please, no cheating. Okay, here are your answers. Okay, if you have any questions on these, you can definitely ask us tomorrow in class. But the reason why I know all my answers are right is because I'm checking it with the loop-de-loop. X squared equals 4. Check. 1/2 to the x equals 5. Good. X to the 6th equals 2/7. Good. A to the 1/5 equals B. B to the 1/4 equals 7. So please, star any that you had trouble with, and we will go over all of this in detail tomorrow. Have a good night.